So sustainable agriculture, soil health, there's a lot of good terms. Resilience, adaptability, but we have to have profit. I mean, a lot of these tests, a lot of these things we're doing, eventually you got to show a return for it, don't you? Let's see here. So I think you'll see the theme of biodiversity, regenerative ag, all these things that are going to help improve the soil, you know, the energy cycling, the physical stability, the resilience. These are all the characteristics that we're looking for. And the challenge is, how do we test for them? How do we measure them? How do we know that we're improving on these characteristics? So you got the properties that you can't change. You know, I'm sorry, if you're given rocky soil, what are you going to do with that rocky soil? You can make some improvement. There's a limit to what you can improve on what you're given. If you're given a sand hill in the middle of your field, what are you going to do about that sand hill? Sell it. So you got to work within the parameters of what you're given. So there's limitations, but all these kind of soils, I think we can look at ways of improving what we're given. So even though you're given some pretty crappy stuff to start with, and I think Dave can vouch for that, you've been given some pretty crappy stuff through the years, there's opportunity to improve upon it. You may not get it quite to the level that your forest soils are, but you can still do things to help improve on it. So don't give up on something that may not be quite what your neighbor has. You'll get there. So Rafiq, we got some traditional tests.
Right. I mean, when you collect your soil and send soil to the lab, what traditional lab do? They will analyze NPK, soil pH, organic matter, lime requirement. But what you are missing? You are missing soil biology, which is the main primer for soil to carry out all the reactions. So soil biology and soil physical or physics, so chemistry, biology, physics, all these combinations that make the soil really good and healthy, not like this. So traditional soil is, oh, you take antibiotic, everything would be fine. No, that's not the right way to move. You have to give a comprehensive analysis and tell farmers that that's what you need. So the current soil health analysis and recommendations, what you will find? You'll find, oh, okay, if you do this test, it will give you everything, and you will be fine. But it's not right, because farmers are the scientists. They know everything, like Dave or other farmers. They're very much well aware that what to do and how to do. So one capsule cannot do everything. And some of the labs, that's what they are doing. Try to sell one thing, but basically they are doing traditional soil testing, but recommending in the name of soil health analysis. So you have to be a little bit careful what you are missing. So,
here, yeah.
So we still like this NRCS soil testing package, which does a lot of good things, but it's a little bit tedious and lengthy. So that's why it takes time and people don't like that much. But it's still one of the finest soil health test kit or tools.
Just not real farmer friendly, I guess you'd
Right.
say. Yep. Oop, we're jumping here. Okay.
So right now we have only 4 labs recognized. Cornell, Ward Lab, and what is that other, Wood Lab and Ohio State. But if you look carefully, Ohio State, we not only do all these tests, but we developed our own test. We don't follow other tests. We developed our test. That's why we recommend farmers that our test based on Ohio results, including other states. So we don't just make something NPK and all this. No, there are biology, there are physics, chemistry, all combination.
Boy, that's really jumpy. Sorry.
So Cornell does a lot of good tests also, but they don't have the, still now they are struggling with the recommendation and management. And they didn't develop any test. They collected information about other tests and combine it and sell it to farmers in their name. World Lab, they developed some, they are using Hennish test and Solvita. They have contributed some, and they did a lot of biological activity, like soil respiration. Alan did this test. So
now this was 3 different dates, the middle of May to the 1st of June, and the multi, the winter pea, and the red clover were cover crops. So these were after wheat established. So going in before corn planting is where we did this. But you can see the sod had pretty good respiration all those 3 times there. And where we did not have covers or we did tillage, there just wasn't the biological activity. So, you know, we've got a lot of tests. This test is kind of complicated, isn't it, Rafiq? You get all the biology, the bacteria, the fungi, and, you know, what does it mean, I guess, is the bottom line. So we've got more to learn on some of these.
Right. This is very complicated because you do molecular level analysis, all this fractionation. At the end, what you want to get? You want to get some biodiversity, but still very difficult. If you want to do this analysis, Ohio State, we can do that. It's $59.99 or $59.90. The lab is charging. Ohio State is much cheaper. We can do that. But we don't recommend. It takes long time, lot of chemical extraction, and ultimately what we are looking, we don't get that. Maybe once in a 5 or 10 year, I would say it's good. But Ohio State, we can do that. So, and it's a cheaper rate.
Yep. And Woods End gives you a nice one-page results, you know, with numbers there. I guess we can't quite see all the different parameters, but it's a...
Some parameters.
Yeah, a lot of good parameters they're testing there. So if you remember on the respiration slide with Solvita, these were done at the same time we just did a soil nitrate test. But what do you see the difference when I said the sod had really good respiration, had high numbers? How about the nitrate? It's low numbers. Does that make sense? It's just a grass sod. So the trouble is, if you just go on the Solvita and look at it and you say, well, sod is the very best because it had the highest respiration. You look at the nitrate, it had the lowest, it's the worst. So which one's right? Well, you got to look at more than one parameter, I guess, what we're getting at. So if you only judge it on one of those parameters, you may be making some false conclusions. So of course, you know, for corn production, you need the nitrogen and you need the biological activity with the respiration. So be careful only relying on one test. You need to look at multiple parameters to make good decisions. Man, there we go. Missouri has another lab, I guess, that we didn't talk about.
And they do PFLA test and other tests, but they're still working on that, and they try to develop and standardize some of the tests. And Ohio State, this is our test. We believe soil organic matter is the core and composite indicator of soil. And organic matter is the main driving force to regulate soil health because it influences biological activity and efficiency. We don't want increased biological activity. We want efficiency and biodiversity and chemical buffering. Soil should be buffered, and it can exchange energy to support the soil functions, and it should improve the aggregate stability. If you have aggregate stability, some people call it physical fertility of soil. That regulates water holding capacity, water movement, oxygen diffusion, all this kind of thing. And the active carbon test we did, and we try to correlate with all the soil properties, try to develop a relationship. So you can measure active carbon and tell or interpret how much organic matter you have or what is the quality or health of your soil. So
you can do a lot of testing, you can spend a lot of money and get a lot of numbers.
Yeah, these are the analyses we did with different labs. Same parameters on different occasion, different analysis by different labs. So we wanted to compare how they work. But table is so big, that's why you have to squeeze the data. Totally different. It doesn't match. One laboratory has low values, same test, another lab has high values. So there is no uniformity in the test result.
So I guess bottom line, if you're working with a lab, stick with it.
Yeah.
And compare between fields, between situations within that lab's results. You'll be accurate that way. The danger is when you compare one lab to another and you jump around, and your results may jump around that way. So stick with the lab. These labs are all good quality. It's just that they're doing different measurements, and your numbers are messed up from one to the other. But within the lab, they're fine.
Yeah.
So this is just showing health scores. You know, it could be 1 to 100, it could be 1 to 50. So within that lab, it's fine. It's just showing, the bottom line. It's quite confusing when you compare the same soil across these. Okay?
So that makes a suggestion. We need to establish an uniformity in soil health test and speak a common language that this test or this value means this. So that way farmers will get the uniform message. And the management decision should be based on those test results, that if you have this much, you need to follow no-till or cover crops or gypsum or manure. It should be management specific and interpretative, so farmers can really use that. So I just put an example what OSU we have been working to develop, how we make interpretation. If we have different categories of soil health, what to do and how to do. So we are still working, but we developed so far a management recommendations based on the test result. So which will be included in the cell phone apps, and finally, if you do this analysis, it will automatically tell you what to do.
Okay. So we got a program. If you registered, you might have seen the flyers. We have some we'll pass out. What we're trying to do is get all the Ohio soil health information on one website. I think we rolled this out last year, and we're continuing to add more to it. So it's simply soilhealth.osu.edu. And there's a lot of different screens and links and information, and we continue to update it there. So I think this is a good product of our signature program.
And under that program, we try to standardize and make some common management options for farmers. So you can add new tests which are really valid and calibrated for wide applicability. So that's our idea. Under this program, we are doing this.
I think I'll put some flyers out here when they leave, they can get. So we did a comparison. With aggregate stability, it's not easy in the field, but what we're after is not to have crusting on your soil. Because when you have real fine soil particles and you get a rain, it tends to seal over. And what happens with the second rain after that? It all washes off, doesn't it? So that's why we have to have soil particles that don't break down, that don't crust, and don't seal over our soils and allow that water to infiltrate. And Rafiq's got a method now you can separate out the sizes of those.
Yeah, this test was done in our lab. If you look at the lower part of the slide, cornfield with chisel plow, you can see this soil doesn't have that much good aggregate stability. Soil disperses all the way. But if you look on the top, long-term grass sod, look at that to the left, those are bigger aggregates, macro aggregates. Look at that, how much. And other particles, the top left is 4 millimeter, 2 millimeter, 1, 0.5, 0.25, 0.125, 0.053 millimeter. Look at that in sod, most of the aggregate stability is macro aggregate. So you don't get that much soil dispersion. But if you look at bottom, it disperses every size of the particle. We don't want that. So it would be runoff.
So it's similar, Rafiq, to what Barry demonstrated here, right?
Yeah, exactly, same way.
Because it settles down, that settling is going to be crusting, and real fine aggregates have settled down. That's not what we want.
But this is more precise. This is more precise, different fractions.
Okay. So, soil health, you need to get the water in through the soil. Penetrometer is a way to test that, to know the depth of where those compaction layers are. And I think some of the extension soil water offices have these penetrometers available, so you know, we encourage you to use that. Another way of looking at how our soils can absorb water is through infiltration. And this is a way, and you can just use like a coffee can, go out, put it down in the soil, maybe an inch or two, pound it down in the soil, and pour like a liter of water, you know, like a bottle that you have, just pour it in there and time it, see how long it takes to soak down through the soil. It's as simple as that. Your timing, then you can compare, well, maybe in the wheel track where it's a little more compacted to between the rows, or maybe this field you did some tillage, and the other field you had cover crops and no-till, and just see the difference in that ability of the soil to absorb that water and hold it versus being stagnant and ponding like we've had, of course, the last few weeks. I think as you drive around, you can tell where the ponding is, but that gives you a method maybe other times of the year just to go out and being real specific and give you some feedback as a simple way of testing that. So I did this, you know, comparing clover, and again, this was later in the summer, early fall, and that was wheat stubble, and then a corn-soybean rotation. And the idea is you want to do it twice. It's like the first inch rainfall, usually it can absorb pretty good if the soil's dry. But what happens when you get that second inch a day or two later? And that's what this red line is showing, how quickly or not that second inch of rainfall got absorbed. So you can see the clover, a lot of good root system, it absorbs that second rainfall easily. Corn-soybean rotation with conventional tillage, it took over an hour, and probably not even then it got absorbed. So that's a drastic difference, you know, by manipulating the soil, by having good infiltration, that you can tell you've got problems going on in that conventional tillage there.
And the other one is chlorophyll meter. We use that, but most of the time this meter stays with the brand because he found a good way to use that meter to find out whether his corn needs any nitrogen or phosphorus. So working with him, we found corn leaf reading, the chlorophyll reading, if it is 38 to 40, you don't need any nitrogen application. So if you don't need nitrogen application or fertilization, you can also see the phosphorus whether you need or not. So this is simple and quick and easy to do right away in the field within few seconds.
Okay.
And so, okay, I'll talk about that. Which one is that? This one?
That.
Okay.
Yep.
I'll show you a result which was funded by CTC from your money. I did this work with Dave Brand for 6-7 years using different types of cover crop blends and zeolite. And we wanted to see how it affects the crop growth and soil biological, chemical, and physical parameters under rain-fed, continuous no-till corn, soybean, wheat with cover crops. The experiment was a randomized complete block design in factorial split plot, established 2011. And we had 3 different types of cover crop mix. If you look at here, we call CC crop 1, 2, 3. And we wanted to see which one is good to add a lot of carbon or organic matter and quality of carbon. Amount is okay, but what quality? That's the main important. So soil can get more labile, good quality carbon to improve the soil health. And I'll show you only few slides. We have a lot of slides. Soil microbes. What we found that under control, which is totally chemical fertilization, and you can look at the result. Oh, it doesn't work. Anyway, so when you have cover crops, look at the cover crops reading. How they increase the microbial diversity and microbial biomass. We measured PFLA, but I didn't show you. I just wanted to show you the microbes. How much increased over a period of 5 to 6 years. And this one is organic carbon, total organic carbon. It increases a little bit, but people might say, oh, it didn't increase that much. We don't want to increase so much. We increase steady level. And 0.1% organic matter increase means lot. So that's what we found, that it increased, and zeolite as a calcium supplement really stabilized organic matter in soil. So cover crop and zeolite, we found good result. And Dave will be one of the author of this publication. And look at that, nitrogen management index. We have proposed a new soil health parameter called nitrogen management index. That means how much nitrogen you have total and how much labile nitrogen you have. So when you combine all these, how much nitrogen you need to apply to your field. It's a little bit integrated, but this is one of the excellent parameters I think we developed as one of the soil health indicator to manage nitrogen fertilization. And then also soil structural index. It's not only structural stability, but different types or different sizes of aggregates and how we make this structural stability. And look at this, both cover crops and zeolite over the years really, really improved. So organic matter getting into the system by cover crops and rotation, and zeolite or lime stabilizes that organic matter. So that's what we want to sequester carbon or organic matter in soil. Oh, and bulk density, compaction. So this is Dave's control soil, and that field is not that great field. It was okay. Look at the initial bulk density in the compaction or the controlled one, and how cover crops over the years decrease. So that's another idea, that how compaction can be reduced by cover crops and calcium-based supplement. Together, one cannot be really used. And what we found, research here and worldwide, this Roundup Ready soybean and corn may not give you everything. You need good soil management and water. And I'll show you this slide. Look at this slide. I just took it last week in Burkina Faso. If you don't have water or good soil management, that's what we are going to get. Soil will be dry, and if we plow, the dust will be coming like 1940s, that Chicago dust storm. So this would happen. So corn, Roundup Ready corn, soybean, good. But without water, without good soil media or good soil, you cannot grow them because they need a lot of nutrients and water. So that's the message I have. Soil health is really, really important to support crop production.
So they kind of summarizing, well, I see it with measurements of soil health. You can go two ways. You can spend the money, send it off to labs, get some good exact data, or you can go out, do like a penetrometer. You can do an infiltration. You can do some of these basic things and learn almost as much by looking at the quality and the infiltration, the water holding capacity, and maybe, with the active carbon test. So we got quite a range of tools now to look at measuring different aspects of soil health, and they're going to continue to evolve. I don't think, we've figured everything out yet, obviously. So stay tuned.
So look for the test which gives you most stable reading or consistent reading and management-induced changes. So if you change management, the test result will change. and consistently change, and you can see the effect. So those are the tests are most important. And economic, sometimes people will ask for, oh, do this test, it will do everything. But it's hard to understand what does it mean. So expensive test doesn't mean it's good. So look for economic, consistent, indicative, and visual test, and which you feel comfortable or trust.
Okay.
Thank
so
you.
we're